Hey, welcome to a new episode of SDV Coffee Talk. Today with two amazing guests, Florian and Robert. Just a short disclaimer from my side. Everything what I say here is my own opinion and has nothing to do with my employer. Should we start with a short introduction? Florian, Robert?
Yeah, I leave. Robert, you go first. My introduction is shorter because I've been here before.
Okay, thank you. Hi, I'm Robert Fay. I'm working at Synopsys. I'm doing product management for TPT, and I'm the author of ATIF, the Automotive Testing Efficiency Framework. My background is I was working 12 years in a VW group, developing multiple kinds of software for vehicle function like charging manager, our sensor door locking component, and some driver assistance. And I'm happy here to join today, Fatih and Florian.
Welcome. Welcome.
Hey, yeah, just a quick intro from my side. I introduced myself quite a few times already on this show, so I keep it short. I've been in the automotive industry for 20 years, 7 years in the what you call the traditional environment, and doing electric power steering systems. And then I was 6 years at Tesla, where I was responsible for the validation on vehicle level of every software release that ever left the company. So about 150 of those per year. And after Tesla, I spent a year at NIO as director of integration for the Linux components. And for, wow, time's flying by, for 6 years now as a consultant at iProcess, bridging the worlds between the traditional and the Silicon Valley players.
Cool, thanks. What is our topic today? Our topic today is actually testing and SDV. This is very, we had this couple of times already before in different episodes, but we have today Mr. Broken Testing in our session. A very special guest. And probably, Robert, you can just start. Why do you call yourself Mr. Broken Testing?
Oh, that is a very good question, Fadi. I was trying to recap that. I think that was related to one of my posts, and I was not really sure who was it, but somebody called me Mr. Broken Testing.
Really? Okay.
Yeah, and I picked it up because I liked it. I liked the claim, and I asked ChatGPT, how to handle that, and he said, "Oh, claimed it for you before somebody else would claim that." I think that would not happen, but I like the idea to be the guy who's telling honest what's going on in automotive, and if something is broken, why not announce it? Because you have to first clarify, okay, what's going on? Why is it so weird sometimes in automotive? Why things are not working? And why not claim it with this Mr. Broken Testing style? So I also prep my icon and my entire LinkedIn profile. People were asking, so now he's going crazy more than ever before. But I said, that it's a phase of time. So maybe that will change in a couple of months or a couple of years. I don't know. At the moment, I feel quite comfortable with these Mr. Broken Testing.
I read your post I enjoy reading your posts because they have some kind of a dark, somehow a theme, somehow dark. It makes it more, this boring automotive more exciting, so to say. Somehow on a, what do you want to what kind of message you want to send out with your posts?
The message is stand up. If you see something is not working, stand up and talk to your colleagues. It's never about the people. What I see in automotive, it's often it's about the system. So people want to change things, and the entire or multiple people in the organization say, "Oh, that is how we did it, like always." We don't know how to change it. And if you ever try to change something really big or something really important in automotive or in any other big company, that is quite hard. Okay. So it's quite hard to find alliances. It's quite hard to partners in crime that help you to force it and to bring in these change. And that is what I want to give it. I have done it multiple times in the past, and you have to go on these topics. If you want to change something, it's not announcing the change one time. That will not help. You have to like I do it with my posts. You have to repeat it often and often until all the people understand, and that is what I want to give to the people. Stay on and make the change happen. If you will not do it, the guys who understand it, whoever will do.
And I think we can all agree that now we are actually in a time where we have big change, right? So we're not talking about small change. We're talking about significant different approaches how we do automotive product development. And we will talk about that in a few minutes with the 24-hour test feedback, continuous testing, continuous everything. And on one hand, what I observe, unfortunately, is that some people who like to do some change get the feedback what Robert just says, like, no, we don't do it this way, so we do it this way, and therefore we stick to that. But now we need some almost radical change, and it's important that like folks like Robert and I pointed out a lot as well, to continue to explain and also to define what this change is, so that people have the visibility. But I've seen more openness for change. Now it's the question of which direction and what to do, right? So 5-6 years ago, there was not even a lot of openness for change. It's like, no, we work well the way we work, right? And that's all right. But now actually there is interest in change, and I think that's exactly what Robert is jumping on, and rightfully so, because we need to help people to understand which direction to change and what to do.
But why this change actually in concept of in context of SDV? I mean, testing is testing, right? I mean, it should not change in SDV, or I mean, testing should be testing, or is there a difference?
I think there is a lot of difference.
Yes, Robert, you go.
What is it?
Yeah, so whenever I explain change in related to automotive, we have to discover, or first we have to discuss. So what is the situation when you started testing in a legacy company? So take any example. So most of the software development started, let's say 15 years ago. So the first starting points of in-house software development. And before that, there was always a constellation between Tier 1 and OEM. And the OEM was in charge of system integration, system testing. And what he got is always some kind of ECU or some kind of system piece. And that was the starting point of building up hill systems. So hill testing, integrating components and checking if these components are working. And the interfaces are, so in comparison to today of software interfaces, the interface was quite easy and simple. So we are talking about an ECU with 1 or 2 CAN interfaces, or sometimes up to 3 or 4, like a gateway. And it was quite easy to say, okay, let's give a stimulation and check if on the outer interface we see the behavior we're expecting from these kind of ECU. And then you extended that to multiple ECUs, multiple sensors, actuators, and you can check the entire chain from, there's an input and I want to see a reaction on the output. And now the business gets more and more complicated. So we have these high integrated servers with a lot of software functionality. And the interface, which was exposed before on a hardware level on CAN interfaces, is now not available anymore on the hardware level. It's now in the software. You have to go deep into the software and you have to understand all these software principles. How does it work? And if you now try to test on the outer interface of the ECU, that is something I would call, I don't know if Florian will agree, so some kind of shadowing. So there are some interfaces, some edge cases you cannot reach from outside. You could reach if you exactly know what to do, and if you're doing debugging and interface manipulation from outside with the hardware interfaces. But it gets more and more complicated when you think about 3 hypervisors, Linux kernels, classic autos, adaptive autos, are all in one ECU and one SoC, and you want to check that from outside. That is really hard. That is really, really hard to test. Harder than 20 years ago when you have the complex ECUs. 20 years ago was maybe IVI or sometimes a body controller, which contains 20 functionalities. That is a joke regarding to what you have today to be testing on a high integrated server.
So what I find funny, just to add on, 20 years ago, we saw the emergence of hardware-in-the-loop testing, as you just mentioned, right? And there was a significant pushback from traditionalists who wanted to do manual testing instead, right? Because the hills were expensive and complicated, and they didn't really find any issues and stuff like this. It's funny now, we are 20 years later, and we have the same situation where now suddenly the hill is defended against the upcoming like simulation and high integration test benches and more complex test systems. But it's the same situation. So now suddenly what was the bad guy 20 years ago is now the guy they try to protect with the single component hills. So it's actually interesting to observe.
But the thing, I mean, you told okay, with SDV many things are changing, but we talked about hills again. I mean, I think this hill testing is too late and too old-fashioned, isn't it? I mean,
let me just add to this. So I think what we always refer to is like the combination of different testing, right? So we want to bring different things together in a picture. So we talk about hills, yes. We talk about sills, so software in a loop. Software in a loop. We talk about VILs, so vehicle in the loop. We're talking about bringing those things together. And one thing SDV actually brings to the table, and that's significant, is that the product can actually support the testing as well. And this is a huge difference right now, because you have a lot of compute power in the product, in the SDV, that can actually help bring out information, data from the vehicles, from the test systems during the testing as well.
Okay. Okay.
And then the other thing, I don't know if Robert wants to jump in. And the other thing is actually the ability to iterate faster on this, right? So because the systems are built, I mean, the SDVs at one point when they arrive, they will be built to iterate through software changes quick and provide feedback on those as well. So this is something that the capability wasn't there before, right? So it was a lot of effort to iterate through software versions before.
Yeah, when you think about it, so the SDV, for me, it is so not the end-to-end or the architecture, the electric architecture. That is an outcome or an idea. So for me, the software-defined vehicle is you can use the same software platform on multiple hardware generations. And what does mean is you have to support multiple hardware. So you go directly into this product lifecycle approach, which means the product will iterate over time.
Correct.
And if you have a product iterating over time, you will deploy this kind of software to multiple vehicles, more than we have done in the past with our normal classic approach with deploying the software to SOP, making some model updates or things like that. So that means over time, we will serve with the same software multiple thousands of cars more than we have done in the past. That means the importance of fast testing gets more and more important, because otherwise you will not be able to deploy new software. Yeah. So what we see at the moment is multiple people are working in parallel on multiple car projects. And that makes the people crazy. I don't know. You're also in a close to automotive company, so I saw it in the past for my software project. You were always jumping between the projects, and the next SOP was always the highest priority, and then you jump to the next. So there was no time for celebration anymore, even 10 years ago. So it was always up and running for the next project, and you have to deliver. Oh, there's an update. There's a new requirement. And that gets more and more crazy if you get more and more cars, if you get more and more variants, if you get more and more configurations of your cars. So the individualism of a car will be more and more. And think about, there is a bug in the field. So you will do an analyzation, you will make an update, and you will deploy it to all the cars, and you want to check each kind of configuration. So software testing, from my point of view, will more and more become more and more important, because it will be an enabler. At the moment, it's sometimes like a blocking point. So that is the last line of defense. Yeah. So, and I hope there will be a change in the future. Like, that is not a blocking point anymore. That is our proof point. So yeah, it works in a car. It works on an ECU. It works on multiple levels. And for me, it's the shift left. So at the moment, a lot of software testing, quality assurance is done on hill testing, is And I think there's also a big portion which is done in a vehicle, and that will change in the future to the software in the loop.
But I mean, automotive development is very much SOP driven, as you told before. Also, I mean, but for SDV, actually, we need to decouple the hardware from software, and I think this is still a big challenge for many OEMs. I mean, that you have different life cycles actually for hardware and software.
Yeah,
but how to do that actually? How to do that? I mean.
And so this is the thing, the word is exactly the right one, decouple the hardware from the software, right? So you actually have software, you have your company's software, and that gets deployed to the different platforms in the different configurations, and of course also with variants and so on. But that should not be attached to an SOP date. Of course, at one point it will be, but from there on forward, you should actually change your approach. And it's interesting when you put the numbers together, you don't actually need a bigger group of software developers. Once you get away from what Robert said, that you have every product has a different group of software developers, and you put them together in a decoupled software development with variants and variant coverage, it's probably give or take about the same manpower you need. I just wanted to mention, so Robert said before we had the SDV and so on, you had like no chance to celebrate, you said, right? So it just came to me. So before we had continuous integration, actually we had continuous firefighting.
Yeah.
Yeah. Okay. This is a different view actually. I never seen this like that.
Yeah.
Okay. Yeah, but this. I mean, Robert, you told this also. I mean, this long that you have a single software on 10,000 different car lines actually. But this is, I think. I mean, if the decoupling doesn't work properly between hardware and software, this will never be efficient and sustainable, I think. And I don't know if this can be really done so easily, because, you know, embedded development and so on, probably you guys know also from your past, tends to be close to hardware. I mean, it's there's no proper abstraction. And then you have this very tightly coupled system. Your software is tightly coupled on your hardware, actually. And this is, I think, still a challenge for many companies to do this properly.
Yeah, I think that is also the biggest challenge at the moment. So how to handle that, and from a smaller perspective, that is already done for smaller products. So as I said, I was responsible for charging management and for central door locking component. That was products which were served as a product. So we iterated over time, and we never redeveloped from scratch for next ECU, for the next car project. We already have done all the variance handling within the software by using parameters. We had an abstraction layer from AutoSAR software components. So the idea of AutoSAR was never fulfilled in the end of the idea that we were able to reuse, because from an architecture point of view, we have one project that was like, we take sender receiver clients. On the next of our server, sender receiver server client communication based. Then there was an update of the AutoSAR version which was used. There were some differences between the how to handle diagnostics. So that were changes between the projects in a vehicle car project, and that was struggling. So we handled that with some kind of wrapper code to make an abstraction of operating system to the application software code. But we were able to do that, and that is something you have to rethink and scale it bigger on the entire car project. So we saw a lot of benefits from this kind of product development approach, and I think that is, in some cases, it is scalable. But you have to rethink what does it mean for the entire software product. You cannot only say, okay, let's jump in all the people, put all these software components onto one ECU. You have to think about communication between ECUs. You have to think about architecture, design, so design patterns, architectural constraints you have to fulfill. And that is a really hard software architecture job for really good architects. And sometimes they are maybe missing, or they don't
Okay.
get the voice within the company to voice up.
But this tight coupling, I mean, as you told, I mean, if we look, for example, on the signal-based communication between ECUs, like CAN and LIN and whatever, this old-fashioned communication, this is signal-based and this is tightly coupled. What do you think actually? How big is the probability that such kind of technology like CAN will survive or be there in SDV context? I mean, if you want to decouple.
I don't know if you can decouple that. So if you think about communication or from CAN communication, that is not somebody choose these kind of communication. That is the kind of how you provide the data from a physical dynamic environment. So speed is a signal which changes over time. You can say, okay, give me the change of speed as a server client interface. But what you have to do is you have to implement these kind of threshold mechanisms. So give me a notification when the speed is above 30 kilometers per hour. Yeah, you can do that, but in the operating system, you have to handle it as a signal. So you will communicate over signals. That is the nature of driving behavior. So that will not change.
I think, especially when it comes to CAN bus communication, I think the companies are already like 2 steps ahead, because if you look at a random Ford, I'm pretty sure that the DVC file used in a Ford F-150 and in the Ford Focus is very similar when it comes to those this information like vehicle speed or something like that. And if I look at the DVC file of a Ford and a Volkswagen, I'm pretty sure that their communication on the CAN bus between the ESP and the speedometer is very similar too. I just wanted to go back. About 20 years ago, the whole automotive industry changed to the platform approach, right? So they understand the idea of building platforms. You looked at the Volkswagen MQB platform, for example, right? This is not that far away from what we're talking about, just that they focus on mechanical platforms and EE architecture, where they put different controllers, software hardware combinations into different platform variants. Now, what we are talking is about like the decoupling, right? So you can build the mechanical product with the EE architecture that has to be agreed within the company. And if you do that, then you can put the software independently on top of that. But it's much harder when you take the existing architecture and software and you try to wrench that backwards into such an approach. When we at Tesla, for example, we never did that. We did it the other way around, right? So we built the vehicle software first, and then we put the EE architecture under it. And that makes it much easier. And this brings you to the idea of having full vehicle software. And I mentioned that in this series before. At Tesla, there's only one file that goes onto the car. The car is then taking it apart and is putting the software into the different components. But from software release point of view, so me as the release signature, I only release one file into the field, and then that is handled through configuration management on the car.
Okay. You have a single software and you configure it on model and whatever. I mean, who's configuring this at the end?
So that's the thing. The car is, and that's the point, right? So you teach the car to understand its own configuration, and so it can build the right software out of the package that you send it over. Robert, you had a question, I think.
Yeah, I was wondering. So when I think about, so you already have these products 10 years and older, they are used for multiple years. So the question in mind always is, oh, did I have to redevelop all these kind of software? And I was wondering, so do you have a recommendation to yes or no, or it depends?
I personally have a strong recommendation to no, don't redevelop it. I mean, looking from the Tesla angle, right? Every embedded controller we had in the car in the beginning was coming with off-the-shelf software. There was no special Tesla software on that. So we put the vehicle gateway in the situation as like the main computer in the car to actually OTA update those controllers without having any line of code changed on the controllers. We just use UDS for that. There's newer things. There's like things like SOVD coming, which is supporting all of that because you will have standard code in each of those controllers. But in the end, you can actually build the SDV with older components as well, if you integrate them right. So you don't have to redevelop your window lifter from scratch, or the software on the window lifter, just because you put it into a software-defined vehicle.
But what changed then? I mean, okay, if we take this, I mean, the old stuff is still there, and you told you can build actually on this old stuff and create a new concept like SDV. What changed then? I mean, what is the change?
So you can use parts of the old stuff, but you have to have a centralized SDV controller. And that can either be the telematics unit, it can be your vehicle gateway, it can be your IVI, whatever it is. But something has to be actually not traditional embedded. Something has to be in the car that actually acts like a computer and not only like an embedded system.
Okay. Okay. And this is a big
what I'm
change
saying is you don't have to replace each and every embedded system in the car in order to create an SDV.
Could we, for example, take I don't know, very recent car and make it to an SDV?
So it's a little tricky because you will have to change the main compute system in the car. But you can actually, if you have access to that, and you can replace that. So, or in other words, to take your challenge, right? If I would take a 2012 Tesla central computer, so that the main display and the gateway, and I put it into a Volkswagen, I could actually achieve the same amount of SDV as I achieved in the 2012 Model S.
Okay, this is really bold statement. I mean, we should probably we should do
together
this
and do that once, right?
Exactly.
Why not? There have been people doing that. I don't know if you ever heard about the Volkswagen Stretchler, which somebody took two Volkswagen T3 buses, cut them half, and made them almost double the length to fit the Tesla batteries in it. And he actually used Tesla systems in an old 1980 something Volkswagen T3. So it's not unheard of. It's a lot of hacking though, and it's getting harder because of course today's systems are much more secured. The 2012 computer, and that's why I used that example. 2012 computer was a little bit more open.
Okay.
But let's take the corner back to the testing, since we have the testing expert here. Exactly. So, and one point I'd like to bring up, and then I let Robert speak to it, is like this: the approach of continuous testing, right? So traditionally, you develop for 6 to 8 weeks, and then you throw that over the fence, and then you test for 6 weeks, then you throw the results back through a ticket system, like back in the day was CM Synergy or something like this, or Change Synergy, and Robert's smiling. And then you had a week of bug fix, and then you had a week of regression test, and then after a total of whatever 16 weeks, you had a release. Now we're talking about continuous testing, and my personal statement is the approach has to be that me as a test team, I'll be ready to release any time with a certain information attached to it. So if somebody wants to make a decision, can we release today or not, I can provide them the information, including a risk assessment and a status, and say, look, this is the risk, this is what we did, you can release it with this amount of risk, you might have to have extra supervision on it, or maybe the risk is too high and we continue and fix some issues and then re-release. So this, my main statement is testing teams should actually prepare themselves to release any time with a certain risk number attached to it.
Okay. Yeah, I would agree on that, and I would to add. I want to, or I made some research on this feedback topic, because I'm claiming one number, and that is a 24 hours feedback. that is what I want to see in the industry as a default, as you mentioned. So when we are releasing software, and I tried to set it up, is so you're implementing a fix, or you're implementing a new functionality, you're waiting for the release date, you bring it into the integration. So mostly it's a handover point from one organization, sometimes one company, to another company, which makes it more unhandy for the people who are responsible for the change. Because if you have two companies and you have to integrate something, how do you test that? You can't. I don't can integrate something and make an integration test if the number of interfaces is too big and I have no requirements. So, and that is the default what I see. If you have an external integrator and you as an OEM hand over software components, how does somebody should know what is the behavior of this component? And the behavior is important to make integration tests. And it is also horrible for an integrator if you get a black box with, let's say, 200, 500 interfaces, because it's multiple components in a composition or something like that, and you have to connect them. How do you know what to connect? And if the answer is by name of the interface, you should try to check your interface specification if that is really a good approach and your interface specification is free of bugs. It is not, I promise you. And when you now see there is one component somebody has to integrate, it is not only one component. You mostly have milestones where multiple teams have to hand over their certain components, and you want to have a full build. I've heard from integration steps taking 20 weeks. Remember, you make a software change, and you get 20 weeks later you get the integrated software build. 20 weeks. I have no clue what I have done 20 weeks ago. I have no clue what I've done 4 weeks ago.
Or 20 minutes ago.
Yeah. It's like I have no clue which month was it. So,
yeah.
And so feedback has to be received as fast as possible. And I think, so if you make a change, you should get feedback from unit testing, from build process immediately. So within seconds. If you have, if you integrate a change in a unit, you should get within a half hour feedback from your application. And the application should be multiple staged tested. So I'm a fan of horizontal and vertical integration. Vertical integration is integrating into your ECU operating system, into your stack. And there's also a horizontal integration. Normally you have on an application layer, you have dependencies to other applications. And it's possible to bring them together and make a test also on that level. And you can do a functionality test from starting point to the end point, so like an end-to-end test. And that is also possible. And all these connected, multiple stage and in small iteration gives you the possibility to get faster feedback. And what most people don't know is with all these tools around, with all these physical simulators, you can run your software. So every component, every AUTOSAR Classic component can be run in a really closed physical simulation environment. It's quite easy to set up these days. And with all these signal-based testing and signal analysis, you can also check most of the errors and bugs within the software application. You don't have to wait it's up and running on the Hill system anymore. So the technology is available for 5 to 10 years. So there are lots of solutions out there helping you to set it up. And yeah, that is the reason why I'm claiming these 24 hours. So from my point of view, it's possible.
I mean, doesn't mean that this very fancy expression shift left has to be established in this context to have this 24 hours feedback.
Yeah.
I mean, many people understand different things under shift left. I had so many discussions. I mean, almost everybody defines it differently. I don't know what you think about that.
Let me take a quick step on that, because as a customer, I don't really care too much for all those signals going around. I care for my user experience, right? So I care if I, turn the knob, does the music go up or down? I don't care if what's the resolution between the radio and the chip in my button, right? And this is something, for example, at Tesla, we brought this up, the fast feedback on vehicle level. And that's what Robert is talking about as well. So I can actually do use case testing. I don't care for all the details and all the bits and bytes, and some of this testing might take longer later. But if I go and I test on the vehicle level and the car doesn't drive, that is a showstopper, right? If it doesn't charge, if it doesn't play the radio, if it doesn't open the door. At that level, I don't care if it doesn't do that because there is a DBC file error, if it doesn't do that because I didn't power up the door controller. At that level, I can give you very fast feedback, and we implemented 4 hours actually. I can give you very fast feedback on the vehicle level if the basic vehicle functionality is still given. And then you can continue with all the other testing Robert was talking about and bring the picture together. But if my integration, and I've seen stuff, right? So if that integration creates a software version which doesn't close the battery contactors. I don't have to spend any more time on that. I have to spend all my time to figure out why does that not happen. So I can actually go down. So basically I go top down in my V cycle and investigate, right? Of course, in parallel, you're running hill tests and so on for corner cases and for different environments and all this kind of stuff. But if on the vehicle level, I already see that the car doesn't drive, I don't, I can actually focus my attention on that.
Okay. Yeah, Robert, what do you think about this shift left? What is your understanding of that?
Are there multiple definitions? So my definition is start as early as possible. That is the unit level, and I made some mathematical calculations on that, and it was quite interesting. So I was open-minded on it, and I made some calculations, and the result was I was very close to the outcome of the McCabe metric. You know the McCabe? So cyclomatic complexity.
Okay.
That is so yeah, maybe in the American sector is McCabe, and that was quite interesting. So for my calculations, it's not the how many lines of code you have. So that is not a good metric, but for the testing purpose, it is the combination of inputs you have to check. And if you have signal interfaces, you have value over time changing. So and you have a lot of combinations, and it makes it. If you want to have a full picture of all the interfaces, even if you use equivalence class analysis and break it down to only representatives, you are limited to a number of 8 to maximum 10 signal interfaces you can check in combination, because it's also exploding and you have these always these timing behaviors. So that's completely different to all what you know from static data and these combinations of static data pairwise testing. You maybe have heard that from a testing purpose. That is in signal-based testing. You have always these timing, and timing means 2 signals. You can connect them. So one is up, one is going down, and then you can build up a really fast, really big number of combinations, and that is including equivalence classes. And that gets you a limit in your head, a limit on your execution time. And so you have to break it down to the smallest kind you can check. I would not say 2 interfaces is a good test, but 3, 4, 5, make the components as small as possible and make it from small to higher level with multiple steps of integration. So, and multiple steps is not only 1, it is 10, it's 11, it's 12. So you can check the integration of 2 units. You just have to set up only a limited number of test cases, because you already have checked the units. If you have a full check of 2 units, you just have to connect both units, and you have to check the interface between these units. And you use equivalence classes to check them, and the asserts, so what is the expected behavior, you already have checked within the unit. So there's like the approach Florian said. So reuse is very important, because if you have a unit, you know it is working, and you're now connecting another interface. So an input interface is provided by another unit. So you extend your interface for both combinations, but the behavior is the same. You're expecting the light will go on, then the light should go on. So, and you just have to check these interface between these components, and you're using functional testing. And for functional testing, you can reuse your asserts you already have described in the unit level testing. And so it's a multiple step up from 1 unit to up to the highest product level. So there's a lot of reusability inside.
I also want to add is that on the development side of things, there can be, with more compute power and smarter systems we have in the car, there's a lot you can do against this kind of like race conditions. That's what you referred to, right? By just like being smarter about how you consume signals, for example. If one is off, just, do a handshake back and double check before you fault the system, stuff like this. So the design of the system can actually have evolution as well. So it isn't that, open for faults that you would have then cover with your gigantic test suites.
Okay. We have an interesting question from the audience. Nizar is asking, with the new SDV validation process, will all system tests switch to SIL, software in the loop? Which tests to run while integrating software into different hardwares before delivery? What do you think about that?
So first, no, but there's a lot of SIL, and it's more and more. And with the emergence of AI-based test systems and so on, we will see much more. But in the end, you will not all switch. So I use the word amended. So we will amend our test systems with SIL. We will not replace them. And what we also talk about is now the vehicle level tests, which is use case based. This is more like the second question here: which test to run. So bring it into the whole system and see how does your product perform to the user, not urgently down to the bits and bytes, but to the user from the outside.
I would like to answer the question in a quite different way, because I between the lines I see a problem. So the question should not be which test should be switched to ZIL. The question should be, how did you start ZIL? So ZIL is not hill without hardware. So even if you, I know that a lot of people or a lot of OEMs handle the task of software integration test or software in the loop test to the hill department, because it is the department with the most competency about, and I think they do a great job with all these hill testing stuff. From a ZIL perspective, the starting point of ZIL is the unit. So it's the code change. You're changing a piece of code, and that runs into application, and that runs into an ECU stack. So on a hill system, we start with hill testing because hill, the ECU or the software on the ECU was our starting point in the hill business. So that was, we got an update of software, and that was the first time we were able to test. So flash the software on the hardware, make an acceptance test, so-called smoking test, thus the ECU is not burning. And yeah, of course, you could also do that now in a SIL environment. But why? If you're able to access sources, try to implement these sources. If you're a hill department, you just want to do ZIL testing on the ODX file. So maybe that is not the best starting point if you really want to do ZIL testing. So you should start with where the code change is starting, and then accelerate. And then you will not ask which tests you have to change. You will ask, which tests did I have not already done in a ZIL and I have to do on a hill environment? And that is more hardware related stuff like IO handling. So IOs will always be checked. So you could set up unit testings on a hill level from put some IO electric interface and check if the software is seeing that. You don't have to do a full test. You maybe also do a full test, but climate checks, that is what you will do on a hill level. Multiple, or how is it called? Multiple hours of running or multiple weeks of running to check if the ECU is robust enough. So that is things you will reuse the tests, and that is what you will do in a hill level in the future. And you will do less functionality checks, because that is what you already done on the application, and you integrated these applications into the ECU, and you already have confidence that this will work also on the hardware.
I mean, there is one question from Turahan actually about continuous integration. I mean, that this appeals sounds very good, and if this is even possible in tier ones because of mindset and capability, how shall we trigger such change without in our organization? He's asking.
So first of all, it has to be coming from the top of the organization. They have to understand, and they have to sponsor that. So if your management doesn't understand why you need that and doesn't approve on that, it's really, really hard to push it from the bottom up. So you need commitment in the company. The second is, I've seen it happening in pilot projects, basically like create a landmark project and then roll it out. It's definitely easier when you start on a new project. So to try to take something, and I talk with some projects, they're like, oh, we're already in production. We only do like change management. That's not the time when you want to implement CI and CT. It is, if you start a new project, it's much easier because it is actually a change in, as you say, in mindset and in strategy. And then I saw Kendrick posting earlier in that, so it's like he dared to change processes once. So that's, I think that's a great point, right? Yeah, exactly. to change the process actually is part of the whole continuous thing. Continuous change is part of continuous integration and continuous testing as well. You have to accept that fact. You cannot decide, let's do it like this and let's do it like this for the next 5 to 10 years. This is just not working.
Okay. There is one question from Vinicius, actually.
Yeah, thanks. I wanted to answer to that one.
Former guest.
Vinicius, this test should happen before you merge your code. So once you get a vehicle level software out of the CI system, that should have been checked by the developers on a single ECU before that. But once the vehicle level software arrives, then I go directly into the car.
Okay.
Thanks for pulling that one up. Else I would have called him later.
I'm happy that Vinicius is joining today.
I mean, yeah, we were talking actually in one episode about shift left, and
I saw it from the other side.
Okay. Yeah, I mean, coming back to this 24 hours feedback, actually, what do you see in the current landscape of OEMs where this is happening? Actually, is it just a dream, 24 hours feedback, or is it somewhere really implemented? Do you see this somewhere? I mean, except Tesla.
I've seen it to Tesla.
Except Tesla. I mean,
no, I am seeing prototype projects where they're working on that. So it's not a pipe dream. The challenge is to bring it then together, right, and to roll it out in a broad fashion. But technically, it's happening in small entities. At least from what I see. I'm curious what Robert sees.
Yeah, that is something I'm not really allowed to share, but I see a lot of things happening, and a lot of people are striving to get these 24 hours. So in individual people, individual companies, individual departments sometimes. So it's depending. I think the question is not who is doing it. So I think when Florian shared, so it is possible to do this change, and you get feedback within 4 hours. I think that is worth to try, because the faster you get the feedback, the better it is for your entire development. So when you think about waiting 5 weeks or 7 weeks or even 1 week, that means as a developer, I'm not waiting until I get feedback. I'm implementing the next change and the next change. And other people rely on my changes. And sometimes they make workarounds to make it work around to get their software up and running. And what happens is you have bugs cascaded by other bugs to work around. If you then fix the bug, the original bug, then you break the entire software system. So that is the problem. And so we have to reinvent the wheel over and over again. And that is why it's very important to get these feedback really, really early. And then
you have to do the numbers, right? So on vehicle level, you have like thousands of developers working on software on a vehicle level. And if they just do one code commit per day, that's thousands of commits per day. So if you wait for a week, right, that's like 5,000 or 10,000 software commits between your change and your test on the vehicle level, right? And so the more atomic you can go, the more pinpoint. Ideally, per commit you do one test, but of course, if you do 1,000 commits per day, you cannot do 1,000 tests. But you have to get it as small as possible. So if let's say when something fails, because something will fail, that you can actually have a very pinpointed origin of this, what change led to this failure. And 10,000 changes is much harder than 500 or a couple of hundred.
But I have a provocative question then. I mean, Google, for example, I mean, a huge IT company with thousands of engineers committing code, but they have probably the biggest infrastructure on earth, I would say, probably, and they can do that. And they do this without breaking any system. And vehicle actually, from the complexity, is not comparable with that. I mean, but they can do that. But why we cannot do this in automotive?
So Google doesn't really have embedded systems, right? So that's
that's
a huge advantage.
Yeah.
Right. So they do run CI/CD as we speak continuously. A huge advantage they have, they are not safety critical, so that makes it a little easier. And as a user of a Google phone, I can tell you that they are not bug free either.
No, this is definitely right. Yeah.
But what they do is actually what we're talking about, just in a much faster fashion, right, and a much larger scale. But every code commit runs through a complex set of tests and gives feedback. And they actually run a mono repo, so everything goes into the same repository. So it's gigantic.
But we can do that also in automotive. Why we don't do that?
That's by choice. At Tesla, we ran a mono repo, and you can do it. The problem is, I think that most people who are in charge of those strategies don't understand how software works, and therefore you don't get that push in that direction. The reason why we actually changed at Tesla is because the people who built our infrastructure, they came from Google or they came from all those IT companies, and they said, no, this is not how you do software. You do software this way, and then we had to add basically the safety aspect to it.
I think Vadi, that is the way how it should work. So like Google does, or like Florian mentioned, like Tesla does it. So there, as an OEM, you should be in charge of the entire software. So you should be able. So that doesn't mean that you have to develop any line of code. That is not necessary in my point of view. But you should be able to do that, and you should be able to detect with any change you do, and you do a commitment or a committee code, that you're able to check the impact on the car level. So, and from that point, when you try to get that, you will understand, oh my God, how many variants do I have with all my cars? So I know Mercedes-Benz had a lot of variants, but VW there was like in the Golf, it had up to trillions of variants possible to configure by a customer. So that is reduced now. But it's always also enough of variants on the entire vehicle level. So, and when we go to Tesla, I can choose color and battery pack, and I don't know.
The difference is that Tesla has a ton of variants you don't see as a customer, because they do facelifts every week instead of every 4 years. But and sorry, I didn't want to cut you off there, but the way they do it is basically they are agnostic to variants. They can have a trillion; it's not a problem. The software is able to handle that because of the way they are architected, and they are handling this the whole update process and the validation process and so on. That's a whole different coffee talk, I think.
Yeah, well, I think that is quite important, and maybe that is a good coffee talk to have in the next session, because the number of variants is really a killer in the testing. Because every variant combination increases the number of test amount you have to do, and that is something you have to handle, because you don't want to have unchecked variants or in a customer facing product.
So there's two thoughts on that. One is you have to have the right strategy to test the variants, that's for sure. And then the other thing is also you can do staggered rollouts, right? So this is something the industry still has to learn as well, that I might test certain combinations of variants and I only release software for them. And then the next week I have maybe more time and I continue with the other ones. And then I release the software for them. But that doesn't work with the current infrastructure that car makers have set up right now, because they basically have only one release.
I mean, regarding this 24 hours, what we talked before, I mean, I think there are many things come in my head now. I mean, we talked about suppliers delivering software. Integration takes, I don't know, weeks and so on. I mean, isn't this also somehow a problem of this supplier structure of OEMs nowadays? I mean, that you are not able to integrate fast and get fast feedback. We were talking so much about that because the supplier management is broken. You know, how suppliers deliver software, because all the software coming from the supplier has to be integrated and fast if you want to achieve this 24 hours feedback.
We have only 3 minutes left. That's a huge question.
I mean, but this is probably for the next episode. But probably you have a short answer for that.
So the short answer is you have to tear down walls between tier 2, tier 1, and tier 0, and OEM, and if there's tier 0s, and they have to work closer together. And we actually start seeing that. There has to be integration in the cloud, for example, during development. In the same time, OEMs have to accept the fact that they get software deliveries which are not final, and they might have actually issues with them. So all this together, but actually the short answer is the collaboration has to be strengthened between the suppliers and the OEMs. They have to get together much earlier and much more frequent.
Okay. But I think there are some contractual issues, IP and whatever. It's quite difficult. I mean, I think it's not so easy. I mean, if you develop software with suppliers, this will be also always difficult. And I don't know how this transition, in this fast feedback should go.
But
Fadi, in such an environment.
Do you really think that the IP is in the code? I don't think so. From my point of view, the code is changing every day, so the IP is not anymore the code itself. It's the surrounding environment.
I'm not a lawyer, actually. I don't know what are the German. I mean, especially in Germany. I mean, how this is regulated. I don't know. I mean, I'm not.
The short answer to your question here is some of those contracts for the next generation of collaboration have to be written differently in order to allow better collaboration, right? And you are right. There are some old contracts which are not allowing to that. But that's also what I meant earlier when I said, like, don't take an old project if you want to start and implementing something. This is the advantage when you have a new project. You have to actually work in a different way with your suppliers, and the other way around. If you're a supplier, you have to pull the OEM in much earlier and test together with them.
Okay. I mean, I think we should definitely make an episode about that. I mean,
yes,
the next one.
Actually, I have a great idea who to invite for that, so I'll let you know.
Cool. I mean, we are coming to an end. This is the last episode actually before the summer break. We go into summer break and we'll meet after, I think in September, probably in this round again, because I have a lot of questions I could not ask. My list is long. Do you want to say something? Last word, Florian, Robert? To the audience.
So there's a couple of comments I will answer in a written format because they go directly to me, and B, we don't have the time right now.
Exactly.
Robert, yeah. Anyway, I'm looking forward to the summer break and then coming back afterwards. I think we had a lot of agreement here in that discussion, but also we see that there's still a lot to talk about.
Exactly.
Yeah. And from my side, I wish you all happy summer. And after returning, think about all the testers struggling with software architecture with bad requirements, and help them. Please help your testers by being better and set up CI environments. It is worth to do. I think that is something we could agree here in this round.
Yeah, this is I think a great closing point. I mean, CI, CD, and CT. I think we should really care about that and talk after the summer break again, I would say. Have a nice summer break and see you in September. Bye.
Awesome. Bye. See ya.